What's up, everybody, and welcome to this first episode. Today we are going to be talking about hydraulics and how they can be used in different applications, and this will be the first ever episode on my channel. So if you want to go ahead and subscribe, like this video, and thumbs up for more, that would be great. We're going to get into the how hydraulics works and all the things that it can be used for, and basically just how it works, give a quick introduction, and in later videos we'll explain a little bit more on some of those other components that you'll see on hydraulic systems and pneumatic systems. So first, one of the things I wanted to get into was just exactly what hydraulics is used for. So I pulled up here just some of the things that you can see hydraulic systems used in. You can see here there's construction equipment with this excavator and this truck here with moving up the dump part of the truck. It's a very heavy weight that needs to be moved, and so hydraulics helps in lifting that very heavy weight. In excavators, you can see there's a hydraulic actuator here helping with the arm and the shovel to move large amounts of dirt that can be very heavy and hard to move. We can also see this in different types of aircraft with the different flight surfaces and moving different ailerons and rudders and everything like that that makes the plane fly. You also see hydraulics in those areas. One of the other areas is also in anything that needs to be lifted that's very heavy. So here's a picture of a car lift for something like a mechanic that needs to move something very heavy like a car so that they can get under it. So there's a lot of different applications that hydraulics can be used in, and where its strengths can come into play and have some real benefits in getting the job done. So moving on, just a brief introduction into what hydraulics is. I have this comes from convergencetraining.com. They have a picture here that I thought was a good picture, showing just a very, very basic hydraulic system. And as you can see here, there's some components here that we'll talk about in future videos, but this is your basic hydraulic system. And if I had to give a quick elevator speech almost about what hydraulics is, it's essentially fluid that moves through pipes under pressure, so plumbing, and that pressure is used to move large surfaces or move very heavy objects. And so here you can see just that basic where the fluid within the system moves through. And like I said, in future videos we'll talk about what all these little components do. But basically the fluid moves through this entire system, and eventually, as you can see here in this hydraulic cylinder, or can also be called a hydraulic actuator, is what that pressure goes into to move. And you can see here it will push up this piston to move whatever you're trying to move with that fluid under pressure, helping that surface to move. So one of the things that some people may or may not know is that in hydraulic systems, you may think hydraulics, hydro, water. So you're like, oh, it's plumbing, is there water in the pipes? It depends for what system that you're using. But for one of the things I pulled up here was different types of hydraulic fluids that can be used for different, depending on what the application is. So within hydraulics, some things may need a hydraulic fluid that won't freeze or won't light on fire. So there will be different chemicals in there that will help for the specific application that you need it for. And also in this picture you can see there's different colored fluids, and so like on this plane here on the wing, you can tell when a hydraulic leak happens. There's definitely this streak of red, and you can see it everywhere, which is partly why it's synthetically colored, so that you can see when there is a leak, so that you can tell when your hydraulic system has an issue with it and that you need to fix it. So just the basic of what actually goes into a hydraulic system is that hydraulic fluid. And like I said, there can be many different types of hydraulic fluid depending on what application you need it for and what specifications you need, depending on your work environment. So as you can see, this airplane is working in the snow, whereas maybe a construction equipment may be working in high heat. So it all depends on which one you need it for what application. So I pull up this video here. This is coming from Galco TV. This is another YouTube video that you can look up here. But they give a good, here's a hydraulic actuator on just to give you a visual representation of what a hydraulic actuator is, this is on a piece of construction equipment pushing that hydraulic actuator, that cylinder, to move a very, very heavy piece of equipment. They can come in all shapes and sizes depending on what you need to move or how much pressure you need. I'll stop the video right here, and this shows a very good representation of a hydraulic actuator, and just a very quick explanation of this. Basically, so you have your cylinder in here, and this goes out to your piston. So what happens is the hydraulic pressure will be pushed in under pressure. Let's say if you want to move this outward, so you want to move it going out this way, you would force the pressure into this side, which would push this piston and push the surface that's connected to this piston outward that way. And then when you'd want the actuator to retract, or the piston to retract, you would force the fluid into this side, forcing out the fluid on this side to come out and go back through up to the reservoir, and would push the piston this way because you're pushing the fluid into this side, filling up this side, which would push that piston to the way that you want it to go. So a very basic representation of what an actuator is, and a very quick explanation. I can get into deeper into the specifics of hydraulic systems in later videos. Also wanted to pull up this. Here's a actuator in real life, and a very basic one. I wanted to make sure that I pulled up a very basic one because some of these can get kind of complicated, as you can see in some of these other photos. But essentially, like I was talking about in the last tab, is that if you want the piston to go outward, the pressure would come in through this way and would push that piston to go that way. If you want it to retract, the pressure would come in through this port here and would push the piston to come back in. So it's very basic. You just push the pressure wherever you want the surface to move. So very, very basic representation. I have pulled up here another website. It's called CPI, or controlproductsinc.com. The reason I pulled this up is, like I said, they can come in all shapes and sizes, and this is a very, very large excavator, which needs a lot of fluid under pressure to move a very, very heavy surface. So they can be very, very small, or they can be very, very big, depending on the application that you need it for. And this one was just an extra one to kind of hone in on that point of how big these hydraulic actuators can, and what the applications can be used for. This is coming from fluidpowerworld.com, but this is just to show you a representation of how big these things can be, just to give you a basic understanding that depending on what you need to move, maybe this is used for a water dam or something like that, to move a very large surface that needs a lot of pressure to move a lot of weight. So it all depends on the application that you need it for. And the last thing I wanted to get to, that I'll get into later videos, is you'll see this hydraulics versus pneumatics. Which one do you need? And depending on what you're looking for. And so there's different. So I pulled this up from Medium.com, which kind of goes into the brief explanation of it. But essentially, just to kind of finish off this video, for pneumatic systems, which, if you don't know, pneumatic systems are essentially hydraulic systems. They just use air instead of fluid to create that pressure. So pneumatic systems generally will be used for lower pressures, as you can see here in this article, and hydraulic systems are generally used for higher PSI, or where larger amounts of weight need to be moved. Hydraulics are generally better at that. So you'll see here that pneumatic systems generally can push out 80 to 100 pounds per square inch, while hydraulic systems can use 1,000 to 5,000 psi, or even up to 10,000 psi. So just goes to show the difference between the two systems, which, like I said, I'll get into a later video. But here they even put in a nutshell, the difference between pneumatics and hydraulic systems. And I wanted to go over this because this is one of the very basic things that you'll see is pneumatics versus hydraulics. What should you use? Which one requires more maintenance, and different things like that. But this is a very basic video, so just wanted to go over a quick introduction to each of them. So like I said, with pneumatics, they use air under pressure, whereas hydraulics uses hydraulic fluid. You can see different examples of this in for pneumatics. It would be like precision drills used by dentists. Your lungs are an example of pneumatic system. A nail gun for like a carpenter or something in a dentist chair. So varied applications where they don't need to move very large things, whereas hydraulics would be something like a dump truck lift or hydraulic lift to lift cars. Jaws lift, blood in the body, which would be a pneumatic system, which would be the scientific, more biology based, and also in cars for like brakes and things like that. So just it goes to show the difference. Like I said, I'm not going to get too far into it, but just to show you what the two different applications can be. So that's all I have for this video. Go ahead and give it a thumbs up, give it a like, give it a subscribe, just to keep up to date with our newest videos. Like I said, this is my most recent and first video that I've posted, and I'm going to post some more about some other areas and get into that a little bit more. Thanks for watching.